Hi, everybody. My name is Ravi Devineni. I have with me Michael Pereira. We're from Northwestern Mutual. Our topic for today is automating security and compliance at scale. We work on a team called DevOps Engineering. Our job is to create tools for CI/CD and DevOps, basically to enable the teams to ship applications faster and in a more secure way. We'd like to thank CDCon for giving us this opportunity to present our work. A little bit about our company. Northwestern Mutual is a financial services company headquartered in Milwaukee, Wisconsin. We have locations in New York City and Minneapolis. Fortune 111, America's best employers for women, best employers for diversity, veteran friendly, LGBT friendly. You can see the theme there, a very inclusive and diverse workplace. In addition to that, we're working on some amazing technologies in cloud and DevOps, and we have some very challenging problems to solve. And we're trying to bring digital transformation to a 160-year-old company. We have great work-life balance. We have very flexible and empathetic senior leadership. It's an amazing place to work. Our agenda for today is we're going to talk about CI/CD pipelines and what it means to secure a CI/CD pipeline, right? And we'll talk about concepts of software supply chain security, right? And embedding security in the pipeline and some of the tools that we have created for automating and enforcing these security controls. Hopefully everyone knows what a CI/CD pipeline is, but I'll quickly summarize here. Remember in the old days, right, when many years ago, when we used to do waterfall development, we used to do coding, testing, deployment to staging, user acceptance testing, and on a weekend, we used to release to production. You can see this was a lot of manual effort, right? Replacing all of that manual effort with automation is essentially what a CI/CD pipeline is. There are many benefits of doing CI/CD, right? You're basically releasing smaller changes in much smaller increments. As a result, there is a faster feedback loop. There's reduced manual errors since a lot of the testing and deployment functions are basically automated. You release to the market faster, and as a result, there's higher customer satisfaction. That's what CI/CD pipeline is, right? This one is an interesting slide, right? This is the number of CVEs that are discovered every year. You can see that there is an uptick in the last 4 years, right? 17,000 in 2019, and over 18,000 in 2020, and same trend seems to be happening in 2021 as well. This averages to about 50 vulnerabilities discovered every day. This is 50 new vulnerabilities that are being discovered every single day. What this means is that basically there are more ways in which an application can be exploited. As a result, obviously, more companies are focused on designing applications with security in mind. Security is definitely a first-class citizen. And this is another example. This is a very useful tool called Sugar. It's used to find secrets and sensitive files across GitHub. This is public GitHub in real time. And you can see here, we ran this for about 30 minutes. And you can see here that there's a lot of secrets being committed to GitHub, right? Things such as Google Cloud keys, AWS keys, private keys, usernames, passwords, database connection strings. These are essentially keys to the kingdom, right? And this is a huge problem that all of these credentials are out in the wild. So the goal of CI/CD security is to find these issues as early as possible, because the later you find them, the more expensive it is to fix it. There is a study that IBM has done, and they do it every year, which basically says that an average cost of a single breach is $3.92 million. And this is the average cost across the world. And in the US, it's even more expensive. As a matter of fact, US is the most expensive country for data breaches, averaging over $8 million, right? And no company is exempt. You will see Equifax, we'll talk about some case studies there, Yahoo, Verizon, and even the US government, they have been breached here. And some of the security breaches here, right? Equifax, for example, this is a well-publicized case, right? About 150 million people's personal data got exposed. That's basically every single adult in the United States. That's all of us. Equifax had to pay $1.4 billion to get out of that. The reason this happened was Equifax is basically a Java application, right? They use a version of Apache. It's an open source Apache Struts 2.2. They had a vulnerability that was discovered in 2017, and you can see the number there. And they never patched it for a whole year at least. As a result, it got exploited, and Equifax is in trouble now. SolarWinds is another popular one from last year. SolarWinds is basically a company that sells a software called Orion. That this Orion platform is basically a network monitoring software, right? They have over 18,000 clients that use this software, including major companies such as Microsoft and Deloitte and Intel, and even federal agencies such as Homeland Security and Department of Treasury. All of their sensitive information, such as emails and personal confidential data, got exposed. What happened there? Right, a malware was inserted into the software. It's believed that this happened through a supply chain attack, basically, right? Through either one of their build or distribution systems or one of their third-party dependencies, right? It's not clear what exactly happened. One of the systems was compromised and a backdoor was inserted into Orion. Now, once Orion's updates made their way to the client servers, the hackers gained access to a lot of sensitive information. It cost SolarWinds a lot of money, right? $90 million upwards of that. And not just that, right? Each one of these 18,000 clients who have installed this update have to go and clean up this code, right? This malicious code. So it's estimated that the cumulative cost could be over $100 billion. And that's a lot of money, right? Not just these, right? That there's a lot of companies, big companies such as Facebook, Uber, Target that were attacked. So is software supply chain security important? Absolutely. So what's a CI/CD pipeline? And we talked about that. And this is basically a sample CI/CD pipeline. You can see here several stages. You can see here in the typical application development process, right? Stages such as idea planning, code, building, scanning, testing, and all the way to deployment, right? And you can see there's a lot of tools that are a part of this, right? Our goal is to make sure our application itself is secure, right? That it doesn't have any vulnerabilities, that by making sure that all of these scannings and several stages in the pipeline are in place, and that is security in the pipeline, right? But not only that, right? This is a lot of tools here. This is our supply chain, basically. These tools have access to your application, right? They have access to your environment variables. They have access to your data. They have access to your business logic also. If any of these tools were to get compromised, we're in trouble too. The hackers need just one of these tools to get compromised to insert a malware, kind of like what happened with SolarWinds, right? Making sure all of these tools themselves are secure is called the security of the software supply chain, basically. This is our supply chain. Secure all the tools in your CI/CD pipeline. That goes without saying. Some of the principles we use here are basically principle of least privilege, right? Essentially making sure that our tools have only the necessary permissions or resources, for that matter, to do the job it needs to do. Other things include minimizing the attack surface area, right? And hence the blast radius, obviously. You want to ensure that all your communications are encrypted. You want to ensure that your underlying operating system is secure. And those are some of the principles. And you can see some of the examples, right? Ensuring repository settings are compliant. GitLab, for example, you want to ensure that merge requests approvals are configured. Nobody's able to merge a merge request without it getting approved by somebody else. You want to have your default branch to be protected. Authentication and authorization, you want to ensure that SSO is enabled on your applications. Security of the pipeline, for example, S3 buckets, right? You want to ensure that S3 buckets are private and not public, right? And they're encrypted. And your encryption at rest and things are encrypted at rest and in transit as well. So how do we do that, right? How do we audit our supply chain? How do we ensure that all of our pipeline tools are secure? The answer is obviously automation, right? And we have done that on our team. And what we have done is basically created a simple rules engine that checks for basic security configurations for all the tools in the pipeline based on the principles that we laid out earlier, all the security principles that we laid out earlier. And it checks for violations on a daily basis, and it alerts the team when something is off, right? Obviously, some rules do fail, and that just means that there is a gap in our system, right? We need to do some extra work to harden the security of that particular tool. And here's an example of the dashboard that we created, and you can see here there are some rules checking for public projects, for example, right? You want to ensure that the code in your source code is only accessible to people within the company. Docker registry. You want to ensure your data is encrypted. And this basically is a good way of identifying all of this data is false data, by the way. It's a great way of identifying gaps in our software supply security, software supply chain security, right? And next one is Michael will talk about securing our application itself and some of the tools that we have created to automate our compliance.
Thank you, Ravi. Now we're going to look into a little more details about the different security controls that we can have inside the pipeline. We have two main types of security scans, static and dynamic. Static ones work with just your code, while the dynamic ones require your application to be up and running, which is more complicated to do in some cases. As you can quickly guess, static ones are easier to run, but don't always provide the best results, while the dynamic ones can be hard to run, but depending on the application, will provide the most accurate result because it's really going to be looking at your application up and running, ideally the same way that it is in production. So let's start from the bottom of the stack. First, we have the OS vulnerability scanning. While it's not specific to containers, it has grown in popularity with the usage of Docker, because now the task of keeping your base system up to date doesn't fall solely on the system administrators. It's also your job. And since we, developer, are quite lazy and forget to do it, we need to do those scans to make sure it happens. Next up the stack, we have the dependencies used by your application. Since we usually don't want to reinvent the wheel, we use libraries to speed up development, make our lives easier, etc. The downside that we have now opened a new attack vector for our application, since we're putting code that we haven't written ourselves. As it's not feasible to view the entirety of the code and all the changes made with each and every version, we delegate the work of security verification to a tool that will execute this scan for us and tell us when we're trying to use a library with CVEs. Finally, we're getting to our own code. After we made sure that the base upon which we are building our app is solid, we need to ensure that we're not undoing all this maintenance work by writing a bunch of vulnerable code on top of it. The code vulnerability tool is going to look at patterns in the code to try to detect things such as SQL injections, access control, XSS, anything that's going to make it easier for hackers to get in. Let us know right away when it finds anything. Lastly, we've included code quality in here, even though it's a little controversial. The reason is that there's some similarities between code security and code quality. If the code is easier to maintain, it's also easier to understand and secure. If it's not readable, it's going to be harder to spot and fix issues. So while not directly a security tool, it definitely helps to keep your code secure. Now on the dynamic side, it's mainly web applications that benefit from these scans, unlike the rest of the scans that work for any type of application. The main reason is that dynamic security scanning tools need to interface with your application, and that's not really something that's trivial to do when you're talking about a rich local client or a CLI application. There are binary scanners available, but the results are not as good as for web application, as far as I know, because they can't send input in the same automated way. Now let's see how each of those we made each of those tools available for our developers. First, the OS vulnerability template. I think this idea. I'm sorry. Simple enough. We call a Docker image and run a script. Nothing too specific. Then we are going to be checking dependencies. Next slide. Yeah. Very similar process. We also save the output in artifacts to make sure to make them available to developers to look at. Same thing for the code vulnerabilities. We embed most of the complexity inside these scripts being called. And finally, you're probably starting to start to see a pattern here. We check for the code quality with a very similar template. And it's only a few templates, but it's already too much to keep track of for a lot of developers. Our job is to focus on application developments, and all of these checks that we keep adding to the pipeline is just additional cognitive load that distracts them from delivering a value, but they're important to have. Plus, those tools are usually changing every few years when contract renewal come in, when new tools are created. So there's a constant rollout of new tools and depreciation of old ones that developers have to deal with. To reduce this cognitive load, we've concentrated all these checks into a single template to make it easier to use and get all the security checks at once. As you can see, we don't have a template for dynamic scanning. It's not that we don't do it, but teams that are doing it are tightly integrating with those tools. It's not easy. We haven't been able to find a way to make it work for all applications in a unified way that we can offer as a template to include. So now that we've done the work to ensure that security issues don't make it into our app when the pipeline is built, we need to know when new security issues are discovered in applications already deployed. For that, we have a weekly scan that we report on new issues. It's not perfect, but until we have better live reporting on auditing from security tools, it works well enough to cover this gap. Now that we have all those scans, we also need to make sure that they are present in all pipelines. We don't want all of this work to be undone by simply releasing credentials in the source code, which, as Ravi said, would be akin to giving the keys to the kingdom to whoever has access to read the code. First, we have a pipeline enforcer. It's a home-built system that looks for these security jobs for GitLab CI and Jenkins. We have similar templates to the one that we just shown above for Jenkins. It looks for the pipeline definition files in repositories whenever changes are made. And it warns developer if they're missing some of those checks right away. If they do, they receive a notification via email with a link to the documentation showing how to resolve the issue, as well as getting their commit marked as failed in GitLab, because it's one thing to warn them, but we also need to kind of force them to deal with the situation. So if they have this setting enabled to only allow a request when the pipeline succeeds, it's going to block them and force them to deal with the issue. Lastly, to make sure this issue is really visible, additional comment is added to the commit itself, so that this information stays with the commit for future reviews. So now we have all the checks on verification in the pipeline. Next, we have a secret detector for detecting secrets, as the name implies. When commits are pushed to GitLab, it's going to process them, looking at their content and try to find secrets, and it's going to validate that those secrets are valid. Git offers you several hooks into the lifecycle of a commit until that commit reaches a repository. So we start from the right with the post receive hook. This means that we let GitLab accept the commit, and then we look at its content. And then we try to make people correct their mistakes. And as you can imagine, it's a tiresome process because it's already committed in the Git history. So if they have to rewrite it, it's a cumbersome process. So we decided to move toward the pre-receive hook. And we are now blocking those commits from being accepted by GitLab. It's much better because now the issue is only on the developer machine, and would-be attackers won't be able to see those credentials in GitLab. But it's still a painful process for people to deal with because they still have to rewrite their local history to get rid of that problem. That's something that most people are super familiar with. So the best way to catch those credentials, as you must have guessed now, is the precommit hook. With the precommit hook, we run this analysis before the commit is created. So now it's trivial for a developer to fix this mistake. Since their changes are still in the Git stage or index, they can just remove the credentials from the file, Git add the file, and attempt the commit again. Here is a quick example of what it looks like when you try to do a commit and the precommit hook blocks you. The output is going to show you which secrets, and as you can see, it's going to block you so that you have a chance to fix the issue easily. We chose to build our own system because we found that the existing open source tools listed here lacked in detection capabilities or had too many false positives, especially when they used entropy. Since none of them did any validation of the secrets, we had a very high rate of false positives. This white paper from IBM is interesting if you're interested in this problem. But if security is not your core business, I would recommend to just go with a commercial detection tool such as Git Guardian to let your security team focus on the findings instead of building custom tools that need to be maintained long term. This type of tools were not around when we started on this journey, but if it had been the case, we'd have thought twice before spending all these man hours on creating that complex system ourselves. I think that's the end of our presentation. I'm going to take a few questions now. Hello, everyone. Ravi?
So yeah, I can, Beth, it's a great question about security rules in OPA, right? If you think about what OPA is, right? OPA is Open Policy Agent implemented by Kubernetes. And by definition, what that means is you have some admission controls at the end of your process, which is at your deployment stage, right? Which is happening at the end of your process. That is great, right? But you do want certain OPA rules for certain scenarios. But you also want to have feedback for some of these supply chain vulnerabilities much ahead in the pipeline, right? Much ahead in the pipeline. And Michael was talking about the pipeline, dynamic scanning the pipeline, and container scanning and things like that. We have to make sure those are happening much earlier. And you can still have certain OPA rules also when you're actually doing the deployment. Hopefully that answers your question.
Yeah, it's currently the way that you use OPA is at the end, but I think there are ways to bring it left and to happen sooner in the pipeline, and hopefully later it's something that we can implement to give a faster feedback to our developers. So the next question is, what data source for vulnerabilities you use for application and for DS? For that, we rely on our vendor tools. So for containers, it's Twistlock. For vulnerabilities, it's white source. So we rely on those vendors doing the work of figuring out what vulnerabilities we have for applications and for DOS. But it's not the only thing that we do. We are also investigating and creating our own tool that looks more generally across security issues to try to get that extra information that sometimes doesn't make it through the vendor. So this way we can kind of double check that we are getting all the information need on. It's not just what the vendor selected.
Just to add to that, Marius, so if you're working for a critical company, right, with a lot of regulations and stuff, so the idea that you need to be compliant for certain reasons. So that is something that the vendors have to be accountable for, right? Whenever you choose a vendor, such as Twistlock, Aqua Security, there's a lot of vendors in this space. You have to ensure that their policies are compliant with your regulations too. And also there's a lot of open source tools that are out in the market for something similar. There's container scanning tools and static scanning tools that are quite open source too. If you were to go that route, then you would then be responsible for your tools being compliant, essentially. So I think put it on the vendor if you're choosing a vendor and you're paying for them, basically.
And for your more specific question about a specific library or tool, that's something that, again, you should try to leverage the vendor to tell you if the library or tool is compliant with your security rules. So there are some extra integrations like at Factory with X-Ray that can block the download of those libraries. So it's the balance. How much do you verify after those libraries are being put in use, or do you provide a list of libraries that you have pre-selected? It's really tough to be on either side. On you can have to find the right balance of check but verify, trust but verify between what you allow the developers to do and what the security team will ask you to do.
Next question from Andres Meskin is Pipeline Enforcer a tool you build yourself, or is it generally available? It is a tool that we built ourselves, but it is not something that we're open sourcing yet, at least. But I think we shared some of the ideas that we used, and those ideas are reasonable enough that anybody can take those ideas and build something of your own, right? This is not like ground-shattering ideas or anything. These are simple ideas, and some of the code that Michael showed is also like fairly simple. Python is not a lot of secret sauce in there, so it's something that everybody can build. You can use those ideas there.
Yeah, the idea being to check that you have those checks in the pipeline. So yeah, it's not that's so some smartness to because now pipelines are becoming more and more complicated. But yeah, it's not like an AI or machine learning system. So definitely something that's that if you can create a web application, is something that you can easily create yourself as well.
Next question from Dennis is, how do you enforce all repos have the pre-commit hook you were talking about earlier? Right, so an easy way to do this is using a global system hook, right? That basically gets triggered after every push event happens. It is at a system level, so every repo is being tracked automatically. So you implement it once, and it's there right at that point. So GitLab has a nice way of doing this. You can store the pre-receive hook code within your GitLab server itself and enable that, and all the code is then scanned right after a push event happens. And you can do several things with that. You can send some notifications to a security team. You can do notifications to the team that is committing the code itself, right? And there's a lot of things that we can do, such as dashboarding and alerting and stuff.
Yeah, with Git, once you put a pre-receive hook, it runs for all the commits received by the server. So then it's kind of up to you to kind of filter out if you want to only apply that to certain groups or something. But once you put a pre-receive hook on a Git server, all repositories handled by that server are going to be checked.
Next question is, what process would be in place to detect new vulnerabilities for applications deployed to production? That's a great question, and I think Michael touched on it a little bit earlier in the talk. We said every day there is up to 50 new vulnerabilities that are being discovered, right? That means that an application that we deployed yesterday, which essentially had no known vulnerabilities, could be vulnerable today because of the fact that new vulnerabilities were discovered and suddenly our application is vulnerable. To get around that, so what we're doing is we're doing a weekly scan of all of our applications that are running in production, a weekly scan basically, right? So we take all the applications that run on production, we go through some of these tools that we mentioned, and we make those tools scan our production applications, and then we get the data from production. And then obviously there's some SLAs for certain high vulnerabilities, and some zero-day vulnerabilities obviously will need a hot fix and things like that. And the process itself takes care of that. Things get into the team's backlog, and then things are done in that fashion.
To be clearer, that weekly scan is more of a catch-all system, because if your application is being actively worked on, as those new CVs are published, the pipeline is going to tell the developer, no, you have an issue as they are making changes. So for applications that are being worked on, that feedback cycle is going to be much faster than a week. And we also have another model that kind of to kind of force everyone to get along with it, is that nothing older than 30 days should be running in our system. So everything keeps it being rotated all the time. So this way we can avoid having those long running applications that have been there forever.
One more minute, guys. So Stephen Barton, yes, thank you. Pre-commit hooks is something that we are also implementing, which is something that pushes the check onto the developers' laptops, right? And that is something we're definitely implementing. That's the next step.
The pre-receive hook is something that we create, but there are a lot of open source examples on how to do it. So if you just Google for pre-receive hook examples, there are repos from GitHub itself that show a lot of examples of stuff that you can check in pre-receive hooks. So at this point, it's up to you to pick and choose or create your own version. For the question on certification, I'm not sure I'm aware of the tools or processes to automate the reporting to get ISO certification. I'm not familiar enough with those things to answer. Sorry. Not sure if you know more, Ravi.
Not really. ISO certification is something that I've heard, but I don't know. Is that a regulation thing? I'm not really sure. But
Yeah.
maybe that's a topic for discussion, King, another day maybe. Um, Dennis is back there. I know GitLab does support global pre-receive hooks, but not global pre-commit hooks. You were talking about later. Yes. Yes. So the pre-commit hook, when we talk about pre-commit hook, we're talking about the actual developer working on their laptops, right? Something that runs on their machine. So you need a way to distribute your whatever your commit hook process is to all of those laptops, right? If you're working with a mid-sized company about 500 developers, you need to figure out a way to distribute that. As long as you have a central way of distributing that, I mean, that code is then the same in all of the developer laptops. So hopefully that should take care of that. And not everybody, and people can disable it also, right? And that's another process issue. But having a pre-receive hook is going to be a guardrail there, right? If someone chooses to disable their pre-commit hook on their laptop, you would still have a pre-receive hook, which will provide some additional safeguards there.
Yeah, the pre-commit happens earlier, but is tougher to implement everywhere because you have to push that software to everyone's laptop. So it's definitely not something easy to do for large companies.
Beth, you had one question. Can you share more details about the security rules engine you used to scan? It is something that we built internally within our company. It is different from some of the tools the vendor tools that we talked about, right? You have to be able to ensure that those security principles that we laid out, right? Those tools are also being compliant, right? So such as encryption at rest, such as authentication with SSO, right? You want to do something of your own, right? I don't know if there's a lot of tools out in the market that do this out of the box. I think that is something that we built on our own. It's a simple rules engine, a simple program Python-based rules engine. I think we covered all the questions here. Thank you for your time, guys.
Thank you, everyone. Thank you, everyone.